Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss problems on addressing modes. So, before going to the problems on addressing modes, we will have a look on what is addressing mode and different types of addressing modes. So, the term addressing mode, it refers the way in which the operand of an instruction is specified. So basically, the instruction is having two fields. So the first field is the opcode, and second one is the operand. So these are the two fields. So opcode. So the opcode, it specifies what type of operation the processor has to be performed. So that is represented by the opcode. So opcode means operational code. Shortly, we can call opcode. It specifies the type of operation that we are going to be performed. And operand. So operand is the data on which we are performing this operational code. So that is a operand. So the operand is the data or the memory location used to execute the instruction. This operation must be executed on some data stored in computer registers or the memory boards. So, in general, we will store the data in the registers, or sometimes we are storing the data in the memory boards. That is nothing but we are storing the data in some memory locations. Okay, so uh, so mainly it is having these two fields, opcode and the operand. Okay, so addressing mode means the way of how accessing the operand, the way of accessing the operand, that is called addressing mode. So that means we can specify the operand in several ways. That means we can specify the operand directly, or we can specify using some direct addressing mode, or sometimes we can specify the operand in the memory location. So these are the various ways to specify the operand. Okay, so for that purpose we have several addressing modes. So these are the different addressing modes that are implied mode. Implied mode, first one is a implied mode, immediate addressing mode, register direct addressing mode, register indirect addressing mode, auto increment or auto decrement mode, direct addressing mode, indirect addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode. So these are the various types here. So we can discuss one by one along with the example. First one is a implied mode. So implied mode example is a CLA, clear accumulator or complement accumulator. Okay, so implied mode. So that means here the operand is specified in the instruction. That means operand is specified as part of the instruction. So that is called. So that means here the operand is stored in the accumulator. So the default register is the accumulator. So that accumulator we are going to clear. We are clearing the accumulator register. So in implied mode, the operand is specified as part of the instruction. So that is the implied mode. Next one, immediate addressing mode. So immediate addressing mode means the operand is specified in the instruction. The operand is specified in the instruction. So the operand can be identified by using hash. So if any number before any number, if hash is there, that represents immediate operand. So move AL comma hash 35. That means the 35 is the operand that we are going to transfer to the register AL. So that is the immediate addressing mode. That means operand is specified immediately in the instruction. Register direct addressing mode. Register direct. So that means the operand is specified in the register CX directly. Okay. Suppose if CX contains some 55. So that means 55 is the operand. So that is specified in the register. So that's why it is called register direct addressing mode. Second one, register indirect addressing mode. So register indirect addressing mode, we can specify move AX comma offset of BX. So BX we have written inside the square bracket. So that means the BX, suppose let us assume BX is equal to 4000. So that means 4000 is not the effective address of the operand. It is not the effective address of the operand. So in BX, 4000 is there. So it will go to the some 400 location is there. Okay. So in that 4000 location, it is having some 2400. So that means 2400 is a effective address of the operand. Okay, but in the register direct addressing mode, the operand is specified directly in the instruction. But here the operand is not specified directly in the register. So in the register, we have stored some address. So in that address, we have a operand. So that is a register indirect addressing mode. Next one, auto increment or decrement mode. So add R1 comma R auto plus. So that means we have specified the plus symbol after the register. It indicates that increment, post increment. Okay, so here the effective address is specified in the register, specified in the instruction. So that means here R auto. So it contains the effective address. Suppose let us assume R auto is equal to 100. R auto is equal to 100. So it is the effective address. 100 is the effective address. So it will go to the 100. So we have a memory. So let us assume 100. So in that we have some data operand, some 54. So 100 is the effective address. So using that effective address, it can access the operand. After accessing, it will move to the next consecutive memory location. That means it will be incremented by 1. So that means it will go to the next memory location. So next memory location is the 101. So this is called auto increment. So after accessing the operand, its register value will be incremented to the next consecutive memory location. So that is called auto increment. Similarly, auto decrement. So auto decrement means auto decrement. So here the minus is specified before the register, specified in the instruction or auto. So that means initially we are decrementing the register content, then we are accessing the operand. Okay, so see here. Suppose if we have a memory like this. Suppose if the memory, if R auto is equal to 100. So in auto decrement mode, it will point out to the effective address. So R auto, it contains the effective address. So it will go to the 100th memory location. After that, it will be decremented. So if decremented, then the address will be 99. Then it can access the operand which is present in that location. Let us assume some 35 is there. So this is the operand. So it will access. So this is a auto decrement mode. Next one, direct addressing mode. So direct addressing mode means the effective address is specified in the instruction directly. So see here. So this is a okay. So direct addressing mode. So direct addressing mode is this one, LDAC 5. LDAC 5. Okay. So that means this one. So the address we can specify by using at the rate symbol, or we can also specify 4001 within parentheses. So it represents that it is an address. So that means it is a direct addressing mode. Direct addressing mode. Okay. Next to indirect addressing mode. Indirect addressing mode. So in indirect addressing mode, the address is specified in indirect way. Okay. So direct addressing mode. So in direct addressing mode, the effective address is mentioned directly in the instruction. So like example LDAC at the rate 4001. Second one is a indirect addressing mode. So in indirect addressing mode, the effective address is not mentioned directly in the instruction. It is given in the indirect way. Next one, relative addressing mode. So in relative addressing mode, see, so if you take example LDAC 5, LDAC 5. So 5 is a address specified in the instruction. So in relative addressing mode, the contents of program counter is added with the address mentioned in the instruction. So address mentioned in the instruction is 5. So that will be the effective address of the operand. Similarly, in indexed addressing mode. So in indexed addressing mode, so the effective address calculation is similar to the relative addressing mode, except the program counter is replaced with the index register. So we have two index registers, source index register and the destination index register. So we can use any of that index register in place of the program counter, so that we can calculate the effective address by adding the contents of the index register with the address specified in the instruction. Next one, base register addressing mode. So the base register addressing mode, it is similar to the index addressing mode, except the index register is replaced with the base register. So we have different base registers, BX register or BP register. So that any one of that register we can use. So coming to the problems on addressing modes. The computer has 32-bit instruction and 12-bit addresses. There are 252 address instructions are there. How many one address instructions can be formulated? So a computer has 32-bit instruction. Okay, so that means instruction size is 32-bit length and 12-bit addresses. So it is having 12-bit address. So the instruction size is the 32-bit length and operand size is the 12-bit. So because you can see the instruction format. So instruction, it consists of two or more fields. So first field is a opcode and second field is a operand. As mentioned in the problem, instruction size is 32. So this total size is the 32. Okay, so 32. The operand size is a 12 bits. Operand size is a 12 bit. And second operand size also 12 bit. So remaining opcode. So opcode is a 8 bit in length. 8 bit in length. Okay. So the number of two address instructions possible, 2 power 8, because here the opcode, in order to represent the opcode, we have 8 bits. So that means 2 power 8, 256 instructions are there, two address instructions. So the number of two address instructions available, 250. So here you can see 250. So the number of instructions are 250 available. So that's why 250. So the number of two address instructions possible, 256, minus available instructions two address instructions are 250. So that is means 6. So 6 instructions left. 6 two address instructions are free, which can be used to indicate the given instruction as a one address instruction. Okay, so that means the maximum number of one address instructions are, so remaining free instructions are 6 into 2 power 12, because the operand size is a 12 bit. So that's why 2 power 12. So that is equal to 24,576. So these many one address instructions are available. So here, see, the instruction size is a 32-bit. So total is 32-bit, and the operand size is a 12-bit. Operand size is 12, 24. So that means the total instruction size is 32 minus 24. So remaining 8. So this 8 is the opcode field. Okay. So the maximum number of one address instructions are 24,576. Second one, an instruction is stored at a location 300 with its address field at location 301. Okay. So already we know. So instruction consists of two fields. First field is the opcode. Second field is the operand. So opcode is stored at 300 location and operand is stored at 301 location. The address field has the value 400. So the address field has a value 400. So 400 is there in the address field. A processor register R1 contains the number 200. So the processor register R1, it contains the value 200. Evaluate the effective address if the addressing mode of the instruction is. So we have different addressing mode. First one is a direct addressing mode. So direct addressing mode means the effective address is given in the instruction directly. Okay. So direct addressing mode. Direct addressing mode means the address field contains the address of the memory location. The instruction is supposed to work with the operand. So see here. So opcode is stored at 300 location. Operand is stored at 301 location. So in the address field we have a 400. Okay. In the address field we have a 400. 400. So that means this 400 is the effective address of the operand. So 400 is the effective address because this 400 is mentioned in the address field. So that's why it is a effective address. Second one, immediate addressing mode. So in immediate addressing mode, the operand is specified in the instruction directly. So that means the operand is specified in the field of the address. So immediate addressing means the address field contains the operand itself. So basically, this operand field. So here this is an address field. It is a address field. But here this is not the address in the immediate addressing mode. So instead of address, the operand is specified directly. So that's why it is called immediate addressing mode. Okay. So the effective address would therefore be 301. 301. Okay. So effective address would be 301. Next one, relative addressing mode. So in relative addressing mode means the address field contains the offset to be added to the program counter to address a memory location of the operand. So here in relative addressing mode, the program counter value is added with the address which is mentioned in the instruction. So here from this is opcode, this is operand. So in operand, in the operand or address field, 400 is there. So this is a 400. And the program counter which holds, see, initially the program counter it stores 300. After the opcode is fetched from the memory, its value will be incremented by 1. So it will become 301. So PC value will be 301 plus the address specified in the value mentioned in the address field is 400. So that is means 701. So 701 is the effective address. So in that 701, in that 701 we have a data, we have a operand. Okay, so that is a relative addressing mode. Next one, register indirect addressing mode. So register indirect addressing mode means the address of the operand in the register. Address of the operand is in the register. The address field in this case contains just another operand. Okay, so R1 it contains 200. R1 contains 200. So the effective address would be 200. So 200. Effective address would be 200 because register indirect addressing mode. Register indirect addressing mode. So R1 contains 200. So in that 200 location we have a data. So that is a operand. Next one, indexed addressing with R1 as index register. So index addressing mode. There are several possible indexed addressing modes, but in this case, it is called indexed absolute addressing. So in indexed absolute addressing, the effective address is calculated by taking the contents of the address field and adding the contents of the index register. So R1 is the index register. It contains 200 value, which contains the 200. So this index value, it is added with the address field. So in the address field, 400 is there. So this 200 plus 400, so 600. So 600 would be the effective address for accessing the operand. Okay. So next question is a two-word instruction is stored in memory at address designated by the symbol W. The address field of the instruction stored at W plus 1 is designated by the symbol Y. The operand used during the execution of the instruction is stored at an address symbolized by Z. An index register contains the value X. State how Z is calculated from other addresses if the addressing mode of the instruction is okay. So a two-word instruction is stored. So a two-word instruction is stored in the memory. Okay. The address is stored in memory at address designated by the symbol W. So first one is a direct addressing mode. So see here. So a two-word instruction. Two-word instruction is stored in memory location designated by W. So that means instruction is like this: opcode, operand. So the size of this instruction is a 2 byte. So 2 byte means it occupies two memory locations. So opcode will be stored in W location and operand is stored in W plus 1 location. So W plus 1. So this Y is the address. Y is the effective address. Okay. So direct addressing mode. So Y would be the this Y would be the direct addressing mode because the Y is specified in the address field. So that's why the Y is equal to the Z. Y is equal to the Z. Okay, next one is a indirect addressing mode. So in indirect addressing mode, the address field of instruction contains the effective address of the operand. Hence, given value Y is equal to M of Y. So Y, this is a Y. So this Y, it contains Y itself is not the effective address. So this Y, it contains the effective address of the operand. So it will go to the Y. Let us assume this is a Y. So Y is this one. So this Y is it is the effective address of the operand. So this is having some data 35. So 35 is the operand. So that 35, the effective address is Y. So it can represent M of Y in a indirect addressing mode. Next, relative addressing mode. Relative addressing mode. So already we have seen relative addressing mode. So in relative addressing mode, the effective address is calculated by adding the contents of the program counter and the address specified in the instruction itself. Okay. So in relative addressing mode, the effective address is calculated by adding the contents of program counter and the address of the next instruction. So what is the address of the next instruction here? W plus 2. And what is the content of the program counter? Program counter is a Y. Program counter is a Y. So the effective address is adding the contents of program counter plus Y, because Y is the mentioned in the address part of the instruction. Okay, PC plus Y. So that is equal to, what is the program counter value stored? W plus 2, because the W plus 2 is the address of the next instruction. So that's why W plus 2 plus Y. So it is the effective address of the operand in the relative addressing mode. Next one, indexed addressing mode. So in indexed addressing mode works like a relative mode. So relative mode, except the address supplied by the instruction is added to the contents of the index register instead of program counter. So this relative addressing mode and index addressing mode, in both addressing modes, the effective address calculation of effective address is similar except the registers. In relative addressing mode, we are using program counter, whereas in index addressing mode, we are using index register. So the effective address is equal to base address plus index address, index register. Okay. So what is the base address specified in the instruction Y? Okay. So what is the index register value stored? Index register value is a X. So X plus Y. So this X plus Y is the effective address of the operator in the indexed addressing mode. Okay. So in this lecture, we have seen what is addressing mode and different types of addressing modes. Then we have solved some problems on the addressing modes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.